Okay, two parallel electrodes X and Y are separated by this distance 1.8 cm. The electric field strength between the electrodes are 2.4 exponent 4 Newton per Coulomb. Electrons are emitted with a negligible velocity from electrode X. Okay, what is the force in the electric field? This is actually very simple questions. Okay, so this is again two parallel plates, yeah. Two parallel plates. Here it use electrodes lah. It's the same thing lah. Plates or electrodes, same thing, yeah. All right. So separated by distance. That means two parallel plate. You're going to use this formula. Two parallel plate. You're going to use this formula. You know, delta V over D. E equal to delta V over D. You're going to use this formula. We're not going to use k cube or r square. Don't use k cube or r square. Use delta V over D. Okay, you're going to use this formula. All right. So right now we have the separation distance between the two plates. This one also need to change to meter. Okay, and then this is the electric field strength. Okay, given. Emitted with negligible velocity from electrode X. So this X is we can say is initial point. Initial point. Yeah, X is the initial point and Y is the final point. Yeah, emitted from X go to Y lah. Electron. So this is the test charge. Q0 is electron charge. It's a negative charge. It's a negative test charge. Yeah, electron is a negative test charge. Negligible velocity. That means initial velocity is zero. Okay. So good. These are the things you need to know. Yeah. Electron is a negative. Electron is a negative test charge. Okay, so what is a force in electric field? So let's calculate the force. Let's calculate the force A. Yeah, force, electric force is Q0 E. Q0 E. I already have the E, isn't it? I already have the E. So Q0 is using electron. Yeah, electron. Okay, remember I just want the magnitude. Yeah, just want the magnitude of it. Yeah, magnitude. So so for force, remember the force last time I talked about for vector quantity. When you want to find the force or electric field for vector quantity, you want to find the magnitude, you ignore the sign. Ignore the sign on the charge. Okay, so I just want the magnitude. I just want the magnitude. Magnitude modulus. It means the charge, just ignore negative sign. Understand? The charge, you ignore the negative sign because electron is a negative charge, but since force is a vector, okay, the charge you just ignore negative sign. Yeah, I just want the magnitude. So I just put a positive value. Electron is 1.6 exponent negative 19. So we don't write negative 1.6. We don't write negative 1.6. We just write 1.6. Understand? We just write 1.6. Ignore the negative sign. Yeah, 1.6 exponent negative 19. We don't write negative 1.6. We just write 1.6. Yeah, even though it's a negative charge. Okay, just want the magnitude. The charge, ignore the negative sign. Okay, electric field is 2.4 exponent 4. Okay, 0.4 exponent 4. So all right, 1.6 exponent negative 19 multiplied by 2.4 exponent 4. So the answer is 3.84 exponent negative 15 Newton. That's my electric force. That's my electric force. Okay, is that correct? That's correct. Okay, that's correct. Okay, so now next, let's move on. Go to question 1. Okay, what's the acceleration of the electron on the electric field? Okay, right now I want to know which case is this movement, yeah, of this That means the motion of charge in the electric field. Which case is it? It refers to which case? Is it a stationary charge? Is it case 1, stationary charge? Or is it case 2, charge moving perpendicularly to the field? Or is it case 3, charge moving parallel to the field? Or is it case 4, charge in dynamic equilibrium? Which one? Look carefully. So I draw out the situation. Yeah, better I draw out the situation. I draw the 2 parallel plate first. Okay, 2 parallel plate. I think let's draw this way. Yeah, let's draw it horizontally. Yeah, because I want to, I want to relate to this one. Okay, I want to relate to this case. So okay, so which one is x? I put this below one is x, the top one is y lah. Should I do this way? X, y. Okay. Never mind. Yeah, whatever. Okay, never mind lah. Maybe I put the x over here, the y over here. Okay. Okay, this is my x and it's my y. Which one is positive? Which one is negative? I don't know, isn't it? I don't know. But just now I write all this information. Electron is a negative charge. It moves from where to where. This is very important. Very important. Okay, which one is positive? Which one is negative? We don't know, isn't it? Okay, but you see, this electron is moved from where to where? This is important, from here onwards. Electron emitted with negligible velocity from electrode X. So it moved from X. The electron charge moved from X. It starts from X. Okay? With negligible velocity. U is 0. So it moved from X to where? So X is considered the initial point. And y is the final point. So I can say it moved. Okay, let's look at here. You say acceleration of electron in the electric field, time travel of electron from electron X to Y. Oh, he traveled from X to Y. Okay, so he moved from X to Y. So it velocity when it reaches Y. Oh, so that means it moved from X to Y. So X is initial, Y is final. So you need to read the whole questions to know the electron go from where to where. This is important. You need to know, you need to read the whole question. It always gives clue somewhere. It always gives clue somewhere. Yeah? It gives clue at the end of the question. You see that? So it moved from X to Y. So electron moved from X to Y. But it starts from 0 velocity. It starts from 0 velocity and then it accelerates. You see, it accelerates. So it can move from X to Y and then accelerate some more. Yeah, acceleration also in this direction. Okay. So that means here he has a final velocity V. So that means this X should be the negative plate. This means the X should be a negative plate. It repel the electron downward to the positive plate. And then electron is attracted to positive plate. Understand? Electron is attracted to positive plate. So the electric field actually the direction of electric field should actually going upward. That's the direction of electric field. Electric field is upward from positive to negative. Okay. So correct lah. Yeah. Okay. I can say that. I can say also the electrostatic force also downward. Electric force on the electron is also downward. The force, this is a negative test charge. This is actually a test charge. This test charge is negative. So the force and electric field is opposite direction. Opposite direction. I did tell you about this before, earlier, about this. Where is it? Yeah, let me show you. You see that when a test charge is a negative test charge, the force and electric field is opposite direction. See that? Look at this one. I see if the test charge is negative, the force and electric field opposite direction. See that? When the test charge is negative, the force and electric field opposite direction. So my assumption is correct. Okay. So this test charge is electron, is a negative test charge. So my force and electric field is opposite direction. You see that? My force is downward. Electric field is upward. So okay lah. So my diagram is correct already. Okay. Electron, it moved from X. You see that? It moved from X. So move from X to Y. So electron is a negative charge. It moved from X to Y. So why the electron will move to Y? Because Y is a positive plate. So electron always attracted to positive plate. That's why you move to positive plate, move to Y. Okay? You start from zero velocity and then accelerate downward. So my diagram is correct. Okay? Okay, so let's continue our questions. Solve it. So question B1. Okay, my acceleration. I want to find my acceleration. So how? So this is the case. What? This is what case? This is like I can say what case is this? This is which case? I can say this is this is what case? This is the I can say stationary charge lah. Stationary charge. Yeah, he moving. Yeah, stationary. Start from stationary charge. Or say charge moving parallel to the field. Yeah, charge moving parallel to the field. Yeah, case 1 or case 3 lah. Okay, parallel to the field lah. Yeah, it moved parallel to the field. Okay, so all right. So let's find out the force first. Yeah, let's find out the force. So how to find? Oh no, you want the acceleration, right? How? Do I have? I have the force ready. So very easy. I can F equal to Q naught. No. I got the force ready, right? And then what's the force? The only force acting on the electron is the electrostatic force. So I can say my total force acting on my total force equal to MA, isn't it? Total force equal to MA, and my resultant force acting on the charge is only the electrostatic force. There's no gravitational force. Okay, because mass not mentioned, right? Mass not mentioned, so gravitational force can be ignored. It's only the electrostatic force. So electrostatic force only equal to mass of electron AA. Okay, so I can find my acceleration using the electrostatic force divided by mass of electron. So 3.84 exponent negative 15. So mass of electron. What is the mass of electron? Can find mass of electron can find from list of constant. Where's my mass of electron? Mass of electron is 9.11 exponent negative 31 kilogram. Okay, 9.11 exponent negative 31 kilogram. Okay, so let's calculate. Okay, divide by mass of electron. All right, so I got the answer. It is 4.215 exponent 15 meter per second square. Okay, so that's the answer, 4.215 exponent 15 meter per second square. Okay, so I got my acceleration already. Is that correct? Yes, 4.22 exponent 15 meter per second square. That's correct. So now, what's my time taken? What's my time taken from going from x to y? So what's my time taken? So this one is a kinematic. Just use kinematic formula, you know, kinematics. So question 2, yeah, question B2. So I already have my acceleration. I have my, okay, initial velocity, time taken. Okay. He said D, separation D, right? He said the separation is 1.8 cm. So this is the D 1.8 cm. This one can be our displacement. This one can be our displacement, isn't it? Can be our displacement. All right. We can take, okay, so let's do it. Yeah, so we already have our initial velocity 0, acceleration. Okay, you want to put the direction downward as negative also can. Direction negative, negative, direction negative, direction downward, because the acceleration downward, so acceleration is negative. And then where is it? Where is it? Okay, acceleration is negative 4.215 exponent 15, okay, meter per second square. And then some more, what is it? D, what is the D? Okay, the displacement also downward, right? Displacement from x to y is downward, so it's negative. Downward, so it's negative. Change to meter, so it's 0 0.0 divided by 100, divided by 100, so it's 0.018 meter. Okay, divided by 100, divided by 100, so it's 0.018 meter. So I can find my time taken. So S equal to, I use a kinematic, S equal to ut plus half at square. So negative, direction downward. Okay, u is 0, right? U is 0. Initial velocity is 0, right? And then acceleration is negative 4.215 exponent 15, and then time square. I can find my time taken. Okay, let's find out. Okay, let's find out. Negative 0.1018 times 2. Okay, and then divide by this value, negative 4.215 exponent 15. Okay, and then square root. So my answer is 2.92 exponent 2.92 exponent, what, exponent negative 9. Second, that's my time. Okay, 2.92 exponent negative 9 second. That's correct. Yeah, that's correct. 2.93 exponent negative 9 second. That's correct. Okay. Okay, lastly, question 3. Yeah, question 3. Find the velocity, final velocity when reaching the electrode. So what's the final velocity over here? What's the velocity, final velocity? What's the final velocity when reaching the y? So that's another variable. So I have the UAST. I can just use V equal to U plus AT. Yeah, V equal to U plus AT. V equal to U plus AT. U is 0. U is 0. Acceleration is negative. Acceleration is negative. Negative 4.215 exponent 15. Okay, exponent 15. So then the time taken is what is the time taken here? the time taken, acceleration negative, time taken is 2.92 exponent negative 9. So what's my answer? 2.92 exponent negative 9 multiplied by negative 4.215 exponent 15. So I got the answer is negative 1.23 exponent 3677 meter per second. Okay, that's the answer. Okay, this one is positive. You know why? Never mind, later I will tell you. So okay, that's correct lah. In terms of value is correct. Okay, this negative is just direction, yeah, direction downward. This negative is direction downward. But why his direction is upward? But why his velocity is positive value? Why my velocity is downward? It is because, okay, why my velocity is negative? Why his velocity is positive? Why my direction downward? Why his direction or velocity is upward? Because this one I assume x at the top. This one I assume x at the top. This x can be also at the bottom. Understand? Okay. I mean, this x can also be at the bottom. X can also be at the bottom. Y can be at the top. So the negative plate is at the bottom. Positive plate is at the top. If the electron start from the bottom, from the electrode X, go to Y, then the, you know, because electron attracted to positive plate, then the final velocity is upward. You see that? The final velocity is upward, positive. Right now my electrode X is at the top. So that's why my final velocity is negative. But if you put the electrode X at the bottom, then my final velocity of electron is upward. So the answer of velocity, whether positive or negative, it all depends on where is your electrode. Your electrode X, is it at the bottom or at the top? So I can say both answer acceptable. Yeah, either V positive or V negative, both acceptable. Okay, it all depends on where is your electrode. Is it XY or YX? Understand? Because the question didn't mention clearly the X at the bottom or X at the top. Okay, it can also not necessarily must be horizontal electrode. It can also be, you know, like this. It can also be X, Y like this, or it can also be Y, X like this. An electrode, is it moving to here, or is it moving to like this? Also can, yeah. So it all depends on your diagram. Yeah, the answer all depend on your diagram. Okay, it didn't mention the electrode. How is it configured? Yeah, how is it configured? Okay, that's all for this question. See you again. Bye.